Hi, this is Lori, and this is my homework for Paul McWhorter's AI on the Edge course. This homework video will cover lessons 10 and 11. So in lesson 10, we're being introduced to speech-to-text models or speech recognition. We're using, after doing just a little bit of digging, we're using some models called vosk, V-O-S-K models. And I found this website up here that appears to be the main website for these models. And you will notice it's not a secure website, and after digging in a little bit, the entity is from Russia. Appears that other folks around the world are working with them, so maybe that's not a cause for concern, but just something to keep in mind, I guess. So just a little interesting. Now, I looked up at what our model, that the English US model that we're using, appears to be this one here, the lightweight model for Android and Raspberry Pi. But you can see there are a lot of different models. Some of them are quite large, probably couldn't use in our application. And of course there are a lot of other languages that we could use too, so that's nice. So I think that's why this type of model might be popular. So now in lesson 10, the homework was simply to use our speech-to-text model and turn on and off an LED using voice commands. So let's take a look at the code. All right, here's the code that I have for lesson 10's homework. It's pretty simple, so just to get our feet wet with this speech-to-text model. So we'll set up our object, set up our LED, and here we go, trying to get this to scroll. Yeah, I'm not scrolling in the right place. There we go. And you can see my while, I'll scroll it up here. Yeah, that's the end. You can see my while true loop. It's pretty simple, just print waiting your command, and I chose the words light and dark because it seemed to work a little bit better with those, but sometimes it just doesn't get what you want. So I use the evil if, elif, else construction. So if it heard light, it would turn it on. If it heard the word dark, it would turn it off. And if it couldn't figure out one of those two things, then it would just say, I don't understand your command, and give you another shot at trying to say it again. And I suspect that a lot of the other students did something similar. And then I have a keyboard interrupt so that we can close out of the program gracefully. So let's give it a go here. Light, dark, light, dark, whatever, light, dark. Yeah, so that actually worked pretty good, but I was really being very careful about how I said the word. So yeah, it worked pretty good. And now over here it's actually I'm a little ways away. Oh, no, it's I couldn't understand what I was saying. Anyways, yeah, maybe we'll close it out here so it doesn't keep going. Yeah, so that's the homework for lesson 10. Pretty straightforward. So let's move on to lesson 11. All right, so for lesson 11, we've been asked to ask the user for a blink rate and then blink our LED at that rate. But we've been asked to allow the user to change the blink rate at any time they want and to switch the blink rate of the LED to that rate, the new rate. So that requires some sort of simultaneous approach, and I knew that threading was one of the options there. And I really haven't done any threading in main Python, regular Python. I did a little bit in the GPS tracker project with Paul on MicroPython. So I decided to try to use the threading library in Python and learn a little bit about it. So I'm not an expert, and this is my first attempt at doing any threading in Python. And so my solution might not be ideal or the best, but this is what I got to do, and I ultimately got it to work, I thought, reasonably well. So my first attempt, though, did have some flaws in it. So once I got my first attempt working, I watched Paul's solution, and then I also watched a couple other solutions from other students. And I saw Charlotte's, where Charlotte use the GPIO0 library blink function, which after I dug into that, because I was curious how it did that, it actually kind of does some background threading behind the scenes that you just don't even have to set up, which is kind of nice. And Charlotte pointed out that when we use the GPIO0 libraries function to blink the LED, that as soon as you update the blink rate, it immediately makes a change in the blink rate. And I thought, well, yeah, that's better, and that's the way it should be. And my first approach here doesn't allow that, and we'll talk a little bit about how that happens and why it's not going to update immediately using the first approach I tried. I imported from the threading library thread, lock, and event. So I needed a way to pass the data back and forth using lock. And then I also needed an event to say stop the blink thread, some way to tell it, okay, it's time to stop the blink thread. The user doesn't want to do it anymore. All right, so that was my first use of these events. So we'll set up everything the way we have before. Let's see, and I'm not scrolling the right direction because I'm a Mac user. All right, get this up just a little bit more. Yeah, it's a little laggy today. So I initially set the blink rate to 0. I don't want it to blink at all until the user tells me some rate. So I didn't have a default start rate. I said, don't blink unless we've got some input. So we start off with not blinking. And creating the data lock here, data lock object. And then I'm also creating the event that will allow us to say we need to end the blink thread. So then here's my blink function. And you can see here in the while true loop for that, if the blink rate is not greater than 0, then it's not going to blink. So when the blink rate is set to 0, it doesn't do anything. But it does keep listening for this event. And if it sees that the blink event is turned to true, then it's going to end this while true loop and end the blink thread. So further down, we set up the blink thread. Yeah, right here. And you can see that we give it the target of blink, but we also give it the argument of event blink so that it knows to watch for that event. And we start the thread. Okay, in the main loop, I decided to poll the user in the main loop. I think Paul did the opposite. He polled the user in his thread, and in the main loop he did the blinking. I'm not sure whether it makes any difference or not, but maybe there's some advantages to doing it one way or the other. I'm not sure. I didn't mess around testing it out, but I'm kind of curious. So if anybody knows and wants to leave a comment, I'll be happy to hear that. So when we're getting ready to ask the user for their blink rate, we acquire the lock. And we take in that blink rate that they type, and we allow them to type a Q to quit. So just go in, and I did lowercase. So if they type a capital Q or a lowercase q, it's going to go into this if statement. It's going to set the event blink to true, which means that that's going to get passed back to the blink thread and tell it to stop. Then we're going to turn the LED low because we want it off before we want to exit nicely and cleanly. I put a little sleep in so that some of these printed messages have a time to get out before the program closes off. So that's what that little sleep is. I don't know whether it needs to be that long, but that seemed to work. All right, so if they want to quit, we've taken care of that. But imagine that the user inputs something else besides a Q that's not a number. Well, I wanted that to be checked for. So we'll take that user input and we'll just do a try and accept inside our try and accept to see if there's a value error. So if they enter something that's text, then it's going to say, oh, nope, you need to enter a non-zero positive number and release the lock and continue. So instead of breaking, we're continuing and going to give them another chance to try to enter a number that makes sense. And same thing here, we're going to check and make sure the rate is a positive number, because maybe by accident they enter a negative number. Then we're going to tell them, nope, you can't do that either, and you get another chance, another continue. Otherwise, if we get all the way through all those ifs, then that means the blink rate is good and it's useful to us. And we'll go ahead and set the blink rate here. We'll print that to the screen just so we know what the current blink rate is, and we'll release the data lock so that things can move forward. And then I have this indented out print statement, so when this program ends, it'll print in main program. I have the keyboard interrupt in here as well, so you could end it with a Q, but you could also end it with a Control C. And so again, it'll signal to the blink thread to end, and we'll put a little sleep in so that the blink thread has a chance to end, and we'll end the main program, but we'll say via the Control C. So we can tell whether we ended it via a Q or whether we ended it from a Control C, and we'll make sure that the LED gets turned off. All right, so that was my first attempt, and it works okay. So enter the blink rate, and so if we do the things that most people would do, like a really fast blink rate, or maybe a slightly slower, or maybe even a 1, it seems to happen pretty rapidly. But as Charlotte pointed out, say you typed in something that you didn't mean to, like you got 2 1s together, and you print it, and then you say, oh, no, I meant a 1, and you try to turn it in. Well, you're going to wait the 11 seconds for it to do the first sleep before you're going to be able to update the blink rate. So now it's updated. So that is kind of a flaw, I think, in it. And so that's why I went on and tried to improve my code. I'll just demonstrate that if I type something on that doesn't work, or I type a negative number, it asks me to continue to try to put a good number in, and if I type a Q, it'll quit. And you can see it does, it's ending, I gotta get into the right window here, a lot of screens going on. It's ending the blink and then ending the main program. So I think everything is closing out correctly, but again, this is new to me, so I hope that's the right way to do it. All right, so let's go on to the improved version. The reason why the rate can't be changed instantaneously is because sleep is not interruptible function in Python. And so that's the main reason. So the other thing that I would need to do is I need another event to trigger that a rate change has occurred. So I have the event that will allow me to close out the blink thread, but I also need an event that will say the rate has changed and we need to stop this blinking with the old way and blink with the new way. Okay, so let me get up here and show the changes that are needed to make this more responsive. So I'm going to create a second event that's called event rate that will signal the change in blink rate. And I'll update the blink function to have both of those events involved in it. So we have to have 2 events. And you can see here, instead of using the sleep, I've just commented it out. And we're now using something to sleep, but it's called wait. And it's connected to the event rate object. So we'll wait the blink rate. But if this gets triggered to true, then it's going to interrupt this statement, get the new rate, and start blinking to the new rate. So that's the bottom line on how it works. So there's just a couple more places that there's some changes. In our blink thread, we'll have to add in the event rate as one of the arguments. And then once we finally get the user input and we know it's a legitimate rate that we want to change to, so I'm getting down to that here, then we need to go ahead and set the event rate to true, indicating that we have a change in rate so that we can trigger that change in the blink rate thread. So you might have noticed once you set that to true, that's great, but now when you go back around to ask the user to potentially enter another rate, you have to set the event rate back to false. And so you might have seen that when I went by, that there's this event rate.clear at the top. So that turns it back to false, so that if we can do another round of event rate changes. So those are the key items that make it more responsive. Now, I'm not sure that this is the best way to do it, but this is what I did. All right, so let's go ahead and run it. So we'll just put in some typical blink rates, so we can just make sure it's working. And 0.5, but maybe we do the mistake where we type 2 ones and we really only meant 1. Oh no, I want it to update. Notice it immediately goes back. It goes to the correct new blink rate that we want using that wait wait method on the event object. So yeah, that's how I got it done using the threading library. I didn't use anything else because I didn't know anything else. So yeah, I'm a beginner at this sort of thing, but that's how I got it to work. So I want to thank Paul for the lessons, and thank you for watching.